Today, we are going to talk about how to include the life cycle analysis of construction materials into the environmental assessment of construction projects. This activity is part of the Erasmus Plus project, Ecological and Innovative Technologies for Recovering Industrial Areas from LCA and Energy Efficiency Point of View. Okay, this presentation is organized following these three main topics. First, a short introduction about what life cycle analysis is, and then an explanation of the methodology and conclusion. And the project for this, what we propose for the life cycle assessment of construction projects. It's to use the budget and the project itself, that information. For that, we can employ the systematic classification of construction works that allow us to define every element that is part of the construction project. Then we have to measure those elements to determine the quantities, perform the quantity surveying of that project. And for that, here we will employ the BCCA, that's Banco de Costes de la Construcción de Andalucía, that's the construction cost database of Andalusia. And together with those elements, we can define a benchmark of economic and environmental budget in order to improve it in the following words. The structure of the BCCA, or the Andalusian construction cost, it's very simple. As you can see there in the pyramid, it has a base of the pyramid. It's the market factors, it's how the construction materials are sold, or what are the market costs at the present moment. From those, we classify them in basic cost. That's the next level of the pyramid. And those are basic elements such as construction materials, machinery, and workforce, like manpower. And from there are auxiliary elements that are put together in order to simplify the cost assessment, and all of those are finally combined into unit costs. Those are basic elements in the construction work that have like a entity by itself. It's like the concrete pad, or the project, the housing ceiling, or the flooring. Those elements that by their own have a constructive characteristic are considered unit costs. And then those are organized by steps inside the construction project, and those are the chapters. So each a chapter is formed by unit costs that take place at a precise moment of the construction project. That means that we start from earthworks and then go to the foundation of the building and grow the structure and so on. The chapters are groups of units, of work units that take place at a particular stage of the development of the project. The next step is what's life cycle analysis? This life cycle analysis will take into consideration all the activities, resources, waste, emissions that are due to one particular product. There in the illustration, you can see we go to the nature and get the arits that are needed to fabricate the bricks. Then we have all those activities in the factory, and then also the bricks need packaging, transportation to the construction site, and then the demolition. So each stage of the life cycle is called from the cradle to the door. The door is the door of the factory, or from the cradle to the site. That's the construction material in the construction site. And then finally, from cradle to grave, that means that all the elements in the construction project ends in a landfill. And opposite to that, it's how we can improve the project by implementing what is shown here up here. That's closing the loop, and it's circular economy in the construction project. And here, for example, is what we can do with the concrete that we can crush and transport um, to the concrete central and produce new concrete. So that way we have concrete made out of old concrete. And all that together here in this diagram, we can see that what we use is those construction cost databases for their structure and their classification of construction works. And then those are combined with life cycle analysis databases that are genetic, for example, EcoInvent. And also we can use environmental product declarations, EPDs, from specific construction materials that show the impact and their life cycle analysis as part of the labeling. And from that, we can combine the quantity surveying of the project with the characteristic of each specific element or construction material. And from there, we can, for example, calculate the water footprint, carbon footprint, embodied energy, or the cost of every single element that takes part of a construction project. And here is an example of how we can perform that. For that, we have here an auxiliary cost. That's the masonry crew. There's a group of people working together. Or we have materials, like in this case, is a tree that we will have in the urbanization project. And here we have the tree, a unit, or the fertilizers, the topsoil, and the frame that keeps the tree in place. And all those elements together are this unit, this construction unit, that it's a tree. Each of those elements, by means of coefficients, each unit kilograms, trees, cubic meters of topsoil, each element is transformed into kilograms using their densities. And then for those kilograms, we can get the water footprint, carbon, or embodied energy. And from there, we have the cost of this unit in euros and also the environmental impact, specifically in these three indicators that we are using as an example. So all this together can allow us to compare the environmental impact of traditional solutions and new solutions, and then using environmental product declarations to get precise information about that specific brand or material. And then thanks to this detailed breakdown of construction elements and this internal structure and systematic classification will allow us to take into consideration every single element that is part of the project. And it allows to quantify the other alternatives and how those can reduce the impact.